All right, here we go. Let's try again. Can you aim it?
All right. Here's where you're going to read how many. It says daytime Friday, 8. Wait, what did ours say? Didn't ours say 7? This could be an alternate optimal solution. Does it change the amount of the maximum audience we're going to reach?
No.
Now, this is a common occurrence. There is more than one solution to some of these problems. It will still reach the maximum, but you'll never get over. Whether you get an alternate solution one way or another, you'll never go over the objective function value. That is the most you can reach, no matter which solution you go with. But what has changed? I can see daytime Friday went from 7 to 8, but what else has changed?
Evening Friday went to evening Sunday.
Evening Friday went to evening Sunday, but there's got to be one more change. What about daytime Saturday and daytime Sunday, 5 and 2? What was that before?
Just one more daytime Friday.
5 and 3. So the Sunday, what happened was, this went to a 2 and this went to an 8. It's possible. There could be more than one solution. But it won't change the 199. Either one I would take.
Does it show anywhere what we actually spent, or is it just assume that we spent the whole budget?
Well, it's easy
That
to
change
figure out
at
what
all?
we spent because, well, right there it is. We spent $282,000.
Okay.
Right there it is. We're only spending 25 of our 75 on Saturday, though. Would this be slack or surplus? How much? Slack or surplus? How much? Slack of how much? 50,000. We're spending 25. We had it less than equal to 75. We're spending. We're not spending all of Friday's money. Slack or surplus? That's right. Slack because it's less than. And then how much slack? 8,000. Right?
Where are these numbers on the other program?
Yeah. Oh, wait. Aren't they? Where's the rest of our output? Hang on. Oh, here we go. No, we would have to calculate it. Let me see. Here is our two. Where? Oh, right here on the left? Oh, it's our lower limit. That's not what we spent. You would have to take, we'd have to go back to the problem and take the cost times whatever the optimal solution is.
You can just add up all the grades.
Yeah, like, hang on, let me go, hang on, I gotta think a second. Where's the, whoops, it's not here. We would just take, this was a 7 times that. This was a 5 times that, and then we'd add it all together and we see if we spend all the money. And then you'd go to this one and just say, okay, what's that optimal solution? What's that one times that? And see if it's. But the Excel, you're right, it's giving you the number where the software is not giving you the number.
You could,
Nice observation. I haven't had that brought up before.
you could also work backwards from the slack or surplus that it gives you.
Yeah, you're right. Good point. There's another good point. Anybody hear that? Go up here to the slack or surplus, and you can subtract it from the right-hand side. What constraint was that? Like, hang on a minute. This is the, I keep hitting the wrong up. There we go. 14 has 10,000 in either slack or surplus. Constraint 14 was less than equal to, gotta go down to 14. Where's the current value? Ernest? Where's 14's current value is 50,000, so subtract, what did it say, 10,000?
Yeah.
And it would be 40,000. Is that what it was, 40,000? I'll go back here and take a look. No, it's 42, that
But
didn't work.
isn't it different because some of those?
Possibly,
Yeah.
possibly, possibly. Extra credit? Oh, there's none in the class. There's none in the class. I'm just saying I would. I'm trying to say I would. That deserves some, if there was such a thing. All right, you ready for the next one? Here we go. Okay, it's gonna get a little harder. You're a financial advisor. Client came in, handed you how many million? $20 million. You got to invest it, but the client says there's only 3 choices. How do they want to invest in? And the hard part about all this is some of these choices If you make the commitment to put the money in this investment, one of them, you gotta leave it there for 2 months, you can't take it out. Another one, you gotta leave for 3 months, you can't take it out, and this is a 4-month gig. You're in charge of how this will be invested for the next 4 months, and at the end of the 4 months, you promise the client that $10,000 will be maturing and ready for this, building that they want to invest in, be part of, to build, this commercial building. I think it's commercial building. $10 million available to start this, to start the 5th month for a high-rise building venture that they're participating in. So let me read this to you. $20,000. They wish to invest in the next 4 months in a way to maximize the total interest earned for the 4-month period. But at least $10 million has to be available at the start of the 5th month. So as the 4th month is ending, anything that's maturing at the end of that 4th month, when added together, has got to be $10 million or more, so that the company will have the money for this high-rise building venture. All right, so $20 million. Here's the 3 investment that you're stuck with. You can go into this government bond, but you're committed for 2 months. So if you get into it right at the start of the 4 months, you're there for month 1 and 2 until the end of that 2nd month. And during that time, it will earn 2% for the 2-month period. That's an unbelievably great interest rate. 1% per month. I'll commit for 2 months for that kind of money. Next, this other choice, 3-month construction loan. It's called a loan, but you're the one loaning. It's an investment where the loan goes out to construction projects, but you have to commit for 3 months. So if you commit money to this, which is excellent rate of return, 6% for 3 months, that's 2% a month. I'd love to put it all in there. 2% a month is crazy money. But can we commit it for 3 months? And then get into it again, because that will take us past the end of the 4 months, and we wouldn't have the money available then for the $10 million high-rise. The last one is, if it doesn't go in that government bond, if it doesn't go in this construction investment, we put it in the savings account, this liquid savings account. It's a special money market fund type account. It's liquid all the time. We can get the money anytime. And we get our interest at the end of each month. Now, my hint for this is, when you are going to have to, at the end of every month, calculate how much interest is going to be accumulated so you can add it to what needs to be invested the next month. And to do that, like we wouldn't take the government, what is the government? Government bond is 2%. We wouldn't multiply however much is in there times 2%, because that just tells us how much interest it made. When that matures, we've got all the money we put in there plus the 2%. So whatever we're putting in there, we're going to multiply it times 1.02. Itself plus the interest. Same with the construction loan. If we put money in that and commit it for 3 months, when it's coming back out, we want to multiply it times itself, what is that, 6%? Plus the interest. So when we multiply it by that, we're saying whatever we had put in there, now that it's maturing, it's all the money we put in plus the 6%, all in one calculation. And that's how much we have available to make a decision on for the following month. Same with that one. Now, every month, if we put any money in the liquid account, the savings account, we have to calculate how much it's going to turn into. We have to decide what to do with that money every single month, because it matures at the end of every month. So we're multiplying that one by 1 point, and it's 3/4 of 1%. So that's going to be 0.0 3/4. 7.5? Does that sound right? That's 3/4 of 1% then? Because if it was 1%, it'd be 0.101, right? So 3/4 of 1% would be 7.5, 75% of 1. Okay, there's our calculations. You ready? Here's some other rules. Let's see, determine how to invest for the next 4 months. And they don't want us to ever have more than $8 million in the government investment or the construction investment. $8 million at any one time. Let me make sure you understand what that means. If we commit to a government investment for 2 months, so end of month 1's coming now, and we got to decide now, things are maturing, how are we going to invest the money that's maturing? We got to also take into consideration there may be money already in the first month's government bond that has not matured yet, and we can't go over $8 million. So if we decide to put more in a government bond, and we got to leave it there for 2 months, we can't go over $8 million. So however much is already there, And if we're deciding to put more there, it's got to be added to it and be less than or equal to 8 million. Same with the construction. That's less than equal, that's less than equal to 8 million. We got to come up with a formula for each of these every single month as it ends to make sure that if we're putting more money into that decision, that it takes into consideration how much is still in there that hasn't matured yet, so it doesn't go over 8 million. That was the requirement. When they handed us $20 million, they said, here's the deal. Don't go over 8 million. And then at the end of that 4th month, we got to come up with a constraint that makes sure that we've got at least 10 million of investments maturing at the end of that 4th month to do the high-rise project. So it's all about when the investments are maturing. If I go into a construction investment in month 1 at the beginning, it's maturing at the end of month what? That's right, this is a 3-month commitment. So construction. Now think of the choices we have over the 4 months. Are you ready? Because this is what has to be decided. How much are you putting in to which investment, which month? In month 1, we have 3 choices. Government, construction, and that savings account, right? Those are 3 variables, because those have to be decided right at the start. Month 2, we've got 3 more decisions to make, because some of that's maturing. The liquid one, the savings, that's maturing. And we have to decide if that money's being put into the government, construction, or savings. There's 3 more choices. Month 3, there's money maturing. Month 1's government one's maturing now finally. Because month 2's over, we're in month 3, we got to make 3 more decisions. Government, construction, or that savings. Month 4, 3 more decisions. Government, construction, or the savings. That's how many variables you have. Because this decision of which investments to use has to be made at the end of every single month, ahead of time. Ahead of time. This is all planned out before the client even got there with the check. We already had the meeting. We know what's about to happen. Here's our plan. They want to hear our plan before they literally hand us the check. And we have to, what is it, maximize something? What was it? What? What are we maximizing? The interest earned. We got to maximize that 2%, that 6%, that 3/4 of 1% is what we're trying to maximize. So our objective function is going to be every one of those constraints, 3 from the 1st month, 3 from the 2nd, 3 from the 3rd, 3 from the 4th, multiplied by their corresponding 2%, 6%, or 3/4 of 1%. That's what we're maximizing. You're going to have, is that 12 variables, right? Is that 12 variables? Sounds like a lot. Look at how this is being organized. G is representing government. If it's G1, that's how much we're putting into that investment in the 1st month. G2, G3, G4, there's 4 of the variables. Construction investment, C1, C2, C3, C4, there's 4 of the variables. And then our liquid account, savings account, L1, 2, 3, and 4. So there's the 12 variables. It's really 3 letters, but with 4 different numbers each because there's 4 different months. All right, here we go. Month 1. Before I get started, let's just think about it. However much we're going to put into government 1, however much we're going to put into construction investment 1, and however much we're going to put into liquid account 1, and we're investing all of it. This is one of the few times you're going to see this. Equals $20 million. The variables are representing the amount of money we're putting in, so there's no reason to convert these to represent money because they already represent money, and the right-hand side's money. That's our first constraint right there. We said we're going to maximize. Here's the objective function. How am I doing this? This is 0.02 times G1, thank you. G1 plus 0.02 times G2. Now, am I supposed to do 0.02 or 1.02? Just making sure. I might as well just show this one instead of writing this all down. 0.02 times G1, G2, G3, G4 plus 6% if we decide to put it in here, here, and here, and here. And 3/4 of 1% if we decide to put money in these. And believe me, there's always going to be money left over we're not sure where it's supposed to go that we'll end up putting it in the liquid account. because all of it's going to be invested the whole time until we get to the end of that 4 months. All right? So there's our objective function. There's the money we're first investing. Right? And then, let's see. Before we look at the answer, I want to say, let's pretend month 1 just ended. Is this maturing, this government bond investment for month 1? No, because it's for how long? 2 months. Is this maturing? No, because it's for how long? But is this maturing? Yes. Month 2, we got to decide what's going to be put in government bond. We got to decide what's being put in the construction investment and what needs to be put in the liquid. But what is it equal to? It's only equal to whatever's maturing. And we don't know right now how much is going to be in there, but we know it's going to be itself plus the interest earned. Right? So that's going to be L1 times 1.0075. There's the only money that we have to decide what to do with in the second month. Because that's the only money that's going to be maturing at the end of the first month. Now help me with month 3. Think about this. I want to do the same logic. My decisions for month 3 is, what are we putting in the government? What are we putting into the construction? What are we putting into the liquid account? And it's going to have to equal whatever money's maturing. Now this is month 3. What is maturing in at the beginning of month 3? At the end of month 2, what's maturing? The government from month 1 now is maturing. And we don't know how much is in there, but we know whatever's in there is going to be multiplied by 1.06. It will be itself plus the 6% interest. And what else is maturing? Come on. All right? The L from the previous month matures every month. So we have an L2 times itself and the 3/4 interest. Right? Is anything else maturing? We got it covered. Do you see the logic here? And right now, based on this logic, this 4th month obviously would be 3 choices again. And then you'd have to figure out what's maturing. We would then have our first construction loan maturing, I think. Is that right? And then this government one from month 2 is now maturing. And of course, we got liquid maturing. Now, here's the rule. Do not hand in any of these answers having any variables on the right side. You must use algebra, write these out, and then use algebra to get these variables to the other side. All variables have to be on one side together. So I'm going to go up here now and get this to the other side. This is L1 times 1.0075. I'm going to subtract L1 times 1.0075 on both sides. Am I losing anyone? I feel like I just felt a vibe in here, like I just lost 2 people. I wasn't even seeing the body language, I just felt it. All right? So if I subtract on both sides, this constraint right here turns into G2 plus C2 plus L2 minus L1 times 1.0075 equals 0. That's all you'll have left on the right. And it's a number, it's not a variable. And now this is ready to be handed in, that constraint. Everybody see that? What would you do to this next constraint to get the G1 and L2 to the other side? Multiply, divide, add, subtract? That's right, say it louder. I heard it over here somewhere. Subtract. Just subtract this one, subtract that one. There are going to be minuses here, and you're going to end up with equal to 0. And then the next one's going to be the same way. So you ready? Here's how it works. Month 1. Here's the 3 choices we have. We're investing every penny of the 20 million. Month 2. Here's our 3 choices, and the only thing maturing is that liquid account, because the G and the C are not going to be maturing. We use algebra, get it to the other side. Doesn't matter what order these variables are in. Obviously, I had this one here and this one here. Doesn't matter. Just get it to the other side. Okay, month 3. Here's our three choices for month 3. Here's what's maturing in month 3. Subtract each of these, get them to the other side. Subtract here, subtract there. There's our 1, 2, 3, 1 equals 0. Before I show you month 4, you have a pretty good idea what you're going to see. Whatever's maturing, then we're going to subtract and get to the other side, right? Here it is. Here's our three choices. But here's what's maturing. That construction 1 from month 1 is finally maturing at the end of 3. Government from 2 is maturing now, and the liquid account from the previous month always matures. Subtract all 3 of these, get them to the other side, equals 0. Here is making sure we have $10 million for the client at the end of the 4th month. It's whatever's maturing at the end of the 4th month. It better be at least $10 million. Let's see, the construction number 2, because construction 1 matured at the end of month 3, construction 2 now is maturing at the end of 4. Government 2, right here, matured at the end of 3, government 3 now is maturing at the end of month 4. Every month a liquid account matures, so month 4's liquid is now maturing at the end of month 4, and those are the only things maturing. And those have to be greater than or equal to 10 million. Now there's one more thing we didn't take into consideration yet. Say it again. I heard you. Say it again, Kevin. Oh.
Very loud.
The 8 million rule. We got to take that into consideration. We can't at any time have more than 8 million in either one of those, government or the construction one. So how does that look? It looks like this. G1 has to be less than or equal to 8 million. And in the second month, if we decide to put more into the government bonds, the 2 of them, what's still in month 1 and in month 2, got to be less than or equal to 8 million. Month 3, well, 1 is maturing, 2 is still invested, but we're going to maybe put more in there. They can't be more than 8 million. Month 4, 2's matured, so it's not there anymore, but 3's still going, and we're putting more in. Picture this now for the construction loan, because that's a 3-month maturity. Of course, there's going to be C1 less than or equal to 8 million, C1 and C2 less than or equal to 8 million, but here's going to be C1, C2, C3 because it's a 3-month commitment. It won't mature yet. Here, C1 will finally be gone because it matures. You'll have C2, C3, and C4 less than or equal to 8 million, and it looks like that. There's C1 the first month. There's the second month. The 3rd month is all of them. C1 finally matures, it's gone, but you still have 2, 3, and 4. It can't be more than 8 million. We've now covered everything. We make sure there's not more than 8 million at any one time. We're making sure there's 10 million left over for the project. We're making sure all 20 million is invested from the very start, and everything that matures along the way, we're reinvesting it, and we're making sure the interest gets accumulated. The objective function is maximizing that interest, because every variable covers every month. You ready? My question for you is, in the very first month, when we invest that 20 million, how much of it is going into the construction loan investments? 8,000.
8,000.
No, 8,000. You're there.
Oh, 8 million.
Thank you. Thank you. 8 million. 8 million. Where is he looking? Someone over here, tell me where he just found that answer. That's right. C1 is the construction investment for the first month. How much are we investing in the government bond for the first month? 8 million. Both of those are more than a month commitment. They're already going to have 8 million in them. So there is no way we're going to be investing more money in month 2 in either of those investments, because neither of them are maturing. We can't put in more than 8 million. Yes, interest will start accumulating, but if we don't get the interest till it matures. So there's exactly 8 million in there for the full 2 months on that first government one. There's exactly 8 million in the construction one for 3 months until it matures. And how much will be in the liquid investment, the savings account, that first month with that 20 million? There's 16 million committed to the other 2, so how much is left?
4 million.
4 million, there it is. 8 million, 8 million, 4 million. There's how we're investing that first month. The money's maturing. The second month, notice, we're not putting any more money in the second month in the government, not putting any more money in the construction the second month. And the liquid, you can see how much money we made off that 4 million in 1 month. Because look how much we had to reinvest. We're making an extra, what is that, $30,000? That's easy money. $30,000 in 1 month on that liquid account, which is only making 0.75%. I want to give you an idea. It was very easy to make 1% a month back in my day, in the 80s and 90s when I was heavy into investing. Right now, it's lucky to make 1% in 6 months. That's how much interest rates have changed. So, you know, this is reality. Making $30,000 in 1 month off of $4 million was realistic, without taking that much risk. Here, liquid 3, but that doesn't, we have some things finally maturing now. Matter of fact, we decided to get back into the government bonds in month 3 because month 1 matured. We're putting in $5,108,613.92 approximately. And this is how you present it to the client. Here's our plan. My question for you is, how much will we make in interest with this plan? Because it's the most we can make in interest and make sure they have the $10 million available at the end. How much are we making in interest in 4 months for this client? Yeah. $1,429,200 and rounded to $14. We're making over $1 million, almost $1.5 million for the client in 4 months, based on some unbelievable interest rates, though, that were reality in the late 80s and early 90s. So there's the mix. You present it to the client, they write the check as fast as they can, and you make it happen. Where are we to do the third one? How much time we got? That's it? 15 minutes? Let's do the in-class. Ready? All right, the in-class assignment. We're going to page. Get your group, blah, blah, blah. You know the routine. Blah, blah, blah. We're going to page 190.
Can I use that?
Okay, forget A, B, C, D. Don't even go down there. Look at number 2. Read the little story here. Look at this. I want you to write, what's our objective here? We have to read the first sentence here. Heartland, solve it. We're not solving it. Hang on. The management at Hartman Company is trying to determine the amount of each product to produce. This is how many to produce. The coming planning period, the following information is labor availability, labor utilization, and product profitability. That last word right there is going to tell us our objective function. I don't even need to point it out. Here's our things. This is product 1. If it goes to department A, there's only 100 hours available, and if product 1 uses 1 hour for each one, 0.35, a little more than a half hour, or not a half hour, a little more than a third of an hour if you're in that department with product 2, and so on and so on. All you got to do is define your variables, write your objective function, write your constraints, compare it, help everybody in your group, compare it to another group on the other side of the room, hand it in. And you start your homework. It's due on Thursday, and the homework's already posted. Good luck. Right?